Guys, let me share my screen. Okay, let me this. So I'm initializing the lab. Let's go and see what we have done so far and what we are going to achieve today. Okay. So if I go there, draw this. We have two spine switches. We have three leaf switches. Okay. So today we are going to enable the Vxlan and see that behavior of the Vxlan. Before that, let's discuss what actually we are going to achieve in the Vxlan. Okay, so there are multiple topology, there are multiple design for Vxlan. Spine 1, spine 2, then we have leaf 1, leaf 2, leaf 3. Okay. So far what we have done here is we have done in between leaf and spine, we have done 3 things. We have done Ospf configuration between leaf and spine. So if I go to spine and check that spine should have the 3 neighborship of the Ospf. Okay. If I go to spine, so run Ospf, you will see that this is the Ospf configuration. All 3 interfaces towards the leaf switches are running the Ospf. We have 2 loopback. One is for the BGP and Ospf neighborship, and second is for the multicast RP configuration. Okay, if I just show IP Ospf neighbor, leaf switches still show interface status. If leaf switches might be initializing, yeah, leaf switches are initializing. Okay. These switches are still initializing. If I see here, let me check the neighborship later. Second thing we have done the configuration of the multicast. Multicast, we have spine switches as a RP. Then we have the sparse mode running across all the leaf and spine switches. Okay, and we have phantom RP. What or Anycast RP? Same concept. Okay, what the meaning of phantom or Anycast RP? It means these leaf switches, spine switches, both the spine switches are acting as a route. It means we have 2 multicast randomized point, and they are running as a combined cluster kind of. Okay, this is we have RP. It means if one fail, one is acting as a both acting as a primary, both acting as a secondary. If any of the one RPs fail, it will not have any kind of impact in the network. Okay, how to check that on the spine switches? If I see here, so run PIM. This is the configuration we have done for the PIM. All the interface are a part of the sparse mode, and if you see that 100.100.1 is the primary RP, and these are the secondary RPs, backup RPs. Okay, similar thing for the spine 2. I say so run Ospf. This is what we have. So run PIM. This is what we have. Okay, so IP interface brief. These are the physical IP addresses. So IP brief. These are the physical. So IP addresses. Okay, if I go, all the tabs are up now. If I show here from the spine 2, it should have the 3 Ospf, 3 PIM neighborship. So IP Ospf neighbor. It has 3 neighborship. from the each leaf 1, leaf 2, leaf 3. These are the loopback address of the leaf. Okay. If I say so IP PIM neighbor, it should also have the three neighbors. 1, 2, 3. Okay. This is the loopback address. Uh, this is the physical interface address of the switches. If I go to the leaf one, spine one also, it should also have the same IP OSPF neighbor. We have three neighborship. So IP PIM neighbor. We have the IP PIM neighbor. We also have the three neighborship. And let's go to the leaf switches. So leaf switch should have the two neighborship. One from the spine one. Second is from second going to be spine two. Okay. If I show you, so IP interface brief. We have how many interface? We have two loopbacks and two interfaces. If I say show interface description, uh, so loopback 0 belong to the for routing purpose, and loopback 1 will be part of the Vxlan NB source. Okay, if I say show an OSPF, we have the OSPF configuration, we have show run PIM. So this is the wrong configuration. Okay, I missed that. I do not need to specify PIM this PIM anywhere. This is just for the spine switch configuration. You just need to specify PIM, this one, as a primary. That's it. So run PIM. So IP OSPF neighbor, if I say neighbors are up, one is from 1.1.1 is spine 1, 2.2 is from spine 2. Okay. So run PIM, if I say, again, it's fine. If I say so IP PIM neighbor, this should have all the neighborship. Tab 1 is fine. If I go to this leaf 2, so IP interface brief, we have 4 interface. 2 is loopback, 0 is for the routing purpose as a router ID, you can say, and loopback 1 is for the NB source, so for Vxlan, you can say, and this is towards the spine 1, this is towards the spine 2. So I say so run OSPF. This is the OSPF interfaces. So run PIM. So run PIM. This is the multicast we have. Again, we have to do the configuration change. If I say no, no again. So run PIM. So IP OSPF neighbor. We have two neighbors. So IP PIM neighbor. We have two more neighbor. Okay. For leaf 3 also. If I go 8 PIM. So IP interface brief, we have again two loopback, two interface, one interface for each spine. We have so run OSPF, okay. And we have so run PIM. No. So run PIM. So IP OSPF neighbor. We have two neighbor. One is from spine 1, second is from spine 2. PIM neighbor, again neighbor with the spine 1 and 2. Okay. Now let's go for further. We have done the two configuration between leaf and spine switches. Now third thing is we have done the IBGP configuration between the leaf and spine. Okay, between leaf, between all leaf and spine switches. What we have done so far, let's check that. Okay, we have just done the basic BGP configuration. Okay, on the spine one, if I say here, So run BGP. This is the configuration. Let me copy from here and paste it here somewhere. Okay, this is configuration from the spine. Okay, and if suppose this is from the spine to this is going to be the router ID change, nothing else. We have IBGP running. Okay, we have address family unicast. We have created the template for the remote users, remote neighbor. This is the remote. This is the source loopback one. We have address family. We have extended both, and we are running a route refactor. So spine switches are going to be route refactored through this command. Since we are specifying that route refactor client, it means we are telling our neighbors, these neighbors, like you are the client, I'm going to be your route refactor. Okay, and we have applied this template under these neighbors. It's leaf 1, leaf 2, leaf 3. Okay, and the same thing we will replicate in spine 2 also. Okay, and let's check the leaf configuration for the BGP. So run BGP. These are the leaf configuration. If I copy from here and paste here somewhere. Oh, sorry. This is the leaf configuration. It's going to be for all the leaves. Leaves. Okay. All leaf will have the configuration. This is going to be local router ID based on the leaf. If it is load leaf 2, it's going to be 9. If it is leaf 3, it's going to be 10. Okay. Based on the loopback, this address family, we are running the neighbor. This is the remote AS, source loopback 0. We are sending the some community. Then we have normal thing. Okay. Again, repeat for spine 2. Let's check them BGP IBGP neighbors. If I go to the spine 1 or 2 anywhere, so IP BGP summary, we should have 3 neighbors. One is from the each leaf switches. Okay, if I do spine 1, so IP BGP neighbor, I should have, sorry, so IP BGP summary, I should have 3 neighbors here. Okay, if I go to the leaf 1 or 2, it should have the 2 neighbors. One is with the spine 1, second going to be spine 2. So IP BGP summary, right? So IP BGP summary. Configuration is same, so run BGP. So configuration like for we have leaf 1, it's going to have for leaf 3 also, just router ID will be changed for each leaf. Okay, so run BGP. Okay, fine. Now it's time to configure the Vxlan. We have the BGP, we have the Ospf, we have multicast. Okay, so far what we have done here is, let's go here. We have multiple steps. Okay, first is IP addressing done. First step. Second step is Ospf done. Third step is multicast done. Fourth step is BGP done. Now, sorry, fifth step going to be in I configuration. Okay. Seven. Fifth stage is we are going to enable the Vxlan VNI. Then sixth step is we are going to create Anycast Gateway. What actually I'm trying to achieve using the Vxlan, let's discuss it. Okay. So what we are going to do here is we are going to create two VLAN, two SBIs. Okay. In those SBIs, sorry, just give me a second. Yeah, we are going to create two SBI, global SBIs, Anycast SBI. This is not the normal. Okay, we are going to have two SBI. One going to have the 150 150. Second is going to have 151 SBI. Okay, this SBI will be using the Anycast gateway. Anycast gateway. and Anycast MAC address. Okay, meaning this SBI Anycast Gateway and MAC address. This SBI is not specific to one leaf. This is not specific to one leaf. This SBI will be used across the all the fabric. I'm calling my leaf, all the leaf, three leaf and spines as a fabric, one fabric. Okay. I'm going to suppose I have one client sitting here. Okay, sitting here. If I have another client which is sitting here, I have third client which is sitting here. Suppose. Okay. Now this, if this client is part of the VLAN 150, this client want to a part of the 151, or this client part of the 150 again. Any leaf can have any any of these two VLAN. It means there is nothing restriction like this leaf particular will have this particular VLAN. It means if suppose any new host you are bringing in the production, you just want to use 151. You can use any of these three switches to connect the 151 because these are the available across the fabric. These two VLANs are available across the fabric. Okay, it means Anycast means we're going to have single IP for each VLAN. That's it across the fabric. We are not going to create this SBI, or you can say, or L3 interface or L3 VXLAN for each individual switches. Okay, this is the Anycast VXLAN concept I'm going to implement today. It means we are going to create two SBI which going to be present across the three switches. Any switches can use any SBI and with the same IP address. All the switches will have these SBI using the same IP address. It means if you are going to create Anycast gateway or Anycast SBI, you must have the same gateway for all across all the switches. Okay, then you can achieve that. If I show you that another format, how we are going to achieve, suppose we have these switches. I'm not going to add these switches. Okay, so we are going to create one big tunnel, okay, which we call that Vxlan tunnel. Okay, we call that Vxlan tunnel or EVPN. Okay, now I'm going to create, each switches will have their own NV interface or tunnel interface towards the each other. Okay, so this is a leaf one, or I can say tab one, leaf one equal to tab one, tab two, tab three. Okay, and now here we have 150, 151. 150, 151. 150, 151. If these user want to talk to each other, they will talk through the external, through this tunnel, whether it's a L2, whether it's a L3. Make sure that they will talk through the tunnel. Okay. Now there is a two types of communication in the between the two VLAN, because we are communicating two VLAN. Okay, if suppose VLAN 150 want to communicate with the VLAN 150, this is going to be the same VLAN communication, L2 based communication, L2 based communication, L2 flood and learn based communication. Okay, if suppose 151 want to talk to 150 or 151 switches host from the different leaf or same leaf. Suppose we have one two here host, right? One can be 150, one can be 151. Similar way here, can be 150, can be 151, right? If suppose they want to do inter VLAN routing, how they can achieve that? So there is two type of concept in a VXLAN. We have symmetric routing, we have asymmetric routing. Okay, sorry, that one. have two symmetric and asymmetric routing. Meaning, so suppose we are creating one tunnel here, right? One big tunnel. If you like to have symmetric routing, you must create the L3 VNI for symmetric routing. Okay? You must have a L3 routing for symmetric routing, L3 VNI. If you do not want to have the symmetric routing, okay, you have to do redistribution between the control plane and BGP and SBI, SBI IP. You have to do the redistribution for the SBI IP addresses, which is going to be complicated for asymmetric routing. Okay? Which is very much not recommended, especially if I deploy any environment, I do not prefer to have the asymmetric routing. What the meaning of symmetric and asymmetric routing here? Okay, if I go with the symmetric routing, we have to create the L3 VNI. It means that VNI, that one we are going to suppose you if you're going for L3, you have to create one tenant. Okay, L3 means tenant or tenant equivalent to VRF, you can call that. If we are going for L3 based communication, you must have to do through the VRF. Okay, without VRF or tenant, you cannot establish the L3 symmetric routing. Okay, and suppose you have under one VRF, suppose you have uh, one VLAN 1 to 100. Okay, and on that, you must create one L3 VNI. Each tenant we should have the one L3 VNI for inter VLAN communication. L3 VNI. Okay, sorry, L3 VNI. Then on top of that, they're going to be the L2 VNIs. Okay, L2 VNI means your all the like VLAN 1, 2, 3, 4, whatever it is. For me, 150, 151. We have VLAN 1, VLAN 2, something like that. Okay, and they are going to associate for L3 traffic for this one. Okay, this L3 VNI will not have any kind of IP address. Okay, this L3 VNI will not have any kind of IP address. This VNI will act as a transit gateway for these VLANs for inter VLAN communication. If suppose these two want to communicate, they will have to come through the L3 VNI because L3 VNI has capability to do the routing. Okay, if I want to suppose go to, and here we're gonna have Vxlan tunnel interface, okay, or NVE interface. Vxlan tunnel interface. Okay, so there is two type of traffic. Okay, suppose similar way, if I got this, sorry, come out. Okay. No, no, no. Okay, suppose I have another same way here. Okay, suppose we have another leaf. This is suppose you have one leaf. Okay, leaf 2. Here we have leaf 3. Okay, and this I'm just creating one tenant for example perspective. In the one tenant, I'm going to associate VLAN 1 to 100. Okay, 1 to 100. Under that, I have another L3 VNI. Then I can have another L2 VNIs. Okay. Then another we're gonna have L tunneling. Then we have Vxlan tunnel here. Similar way here, we have 150 VLAN, for example, our case, we have 151. Okay, it suppose can be VLAN 1, 2, whatever you want to use. Okay, and this is L3. L3 VLAN, if I say here, it's going to be the VLAN. Okay, so for me, I'm going to use 1, 2, 3, 4 VLAN. Okay, 999 or 49 VLAN, L3 VLAN. Now, if suppose the user want to 150, the moment you create that Vxlan tunnel, there is going to be two types of traffic. Okay, first is L3, L3 Vxlan traffic, then going to be the L2 Vxlan traffic, L2 Vxlan traffic. Okay, what I mean by that, so if suppose 150 VLAN want to talk to 150 VLAN, this is going to be the pure L2 communication. If suppose traffic is from 151 to 151, they will go through the L2 VNI. This is going to be a bridging communication. Okay, if this suppose 151 VLAN want to talk to the 152 VLAN, this traffic will be like this. I'm sorry, like this.
So Vijay, this is happening in same DC,
Same
right?
DC, exactly. So I'm just talking about just simple concept here, same DC. Okay, then after that we will come with the multi DC concept. Okay, this kind of, then again we have tunnel, we have to make the communication to this. Okay, this is how the L2 L3 traffic will come, and for L2 L3 always traffic will be through the 99949, whatever we have transit VLAN. Okay, for L2 it can be 150 and 151. This is how the L3 VNI concept is coming. If suppose you have requirement, this suppose you have two customers in your environment. Okay, one is customer one, which they want to use these 100 VLAN, and your production environment second customer came and say that I don't want to share my information to other customer. Create different tenant, like tenant one, tenant by, or VRFY. Okay, and allocate one VLAN for me, like VLAN 200 to 300, right? 100 VLAN for them. You have to create another L3 VNI for them. Okay, you have to create another L3 VNI.
Vijay, sorry to interrupt.
Yeah.
We like you're saying VRF, right?
Yes, tenant is equal to
Via
VRF.
VRF or VNA?
Yes.
Without VRF, we are doing right by using VNI,
No, no,
different VNI
without,
ID.
no. Without VRF, if you are going to use, it's going to be L2 communication. Okay. If you want
Okay.
to have the L3 communication, you must have the VRF, which is equivalent to tenant. Okay. VRF going to have the L3 feature for you to make the communication. And that L3 VNI, one L3 VNI going to be per VRF or per tenant. Okay, if you have 100 VLAN, you must have one L3 VNI, L3 VLAN to have the L3 communication. For this case, I'm going to
Okay.
use like one 251, for example, or you can use any VLAN. Okay.
Okay, so if 100 users are there, then they should connect to one L3 VNI, right?
L3 VNI, exactly. So L3 VNI will be per tenant base. If you have the two VRF, per VRF going to be one L3 VNI. Okay.
So tenant means like here is a kind of domain, right?
It's a kind of domain. So you are creating your boundaries, L3 boundary.
Okay. Okay.
Okay. So let's start the configuration and let's achieve this one first. Okay, we are going to use VRF tenant one. So let's go here and start the configuration. if I go here, what we are going to achieve, we are going to create VNI creation. We are going to do VNI creation. Okay. So this is how the our route refactor is looking. Okay. IBGP we are running between them. We are running the OSPF. We are running the multicast. So if I go to here, not going to touch anything. Okay. These are the two VLAN we have. Three VLAN we have. Okay. I think just 150, 151. Okay, so we have 150, 151. And the purpose of this scenario to enable the VXLAN feature, VLAN VNI multicast group. So this L2 will be part of the multicast group, and this going to be part of the L3 group. We are not going to keep L3 VNI or transit VNI as a multicast. Okay, so they need L2 communication, and this need only L3 communication. So we are not going to associate transit VNI with the multicast group. Okay. Okay. So first thing is we have to enable this feature NV overlay. Then we have to create NV segment VLAN base. Why NV segment? If you want to enable the VXLAN, you must have the NV segment for this one. So let's take a look. What is the feature providing to us? Just give me a second. What all these commands going to provide us? Okay, so NV overlay command will enable the tab requirement. Okay, so without this command, we cannot create the Vxlan tunnel. Without this command, we cannot enable the Vxlan control plane with the BGP. Okay, these are the two commands which are important. And yep, so we are going to create here VLAN to L2 VLAN or VLAN mapping. Okay, this one. And this one will come to later. Let's go and enable the feature. If I go to the leaf one feature, let's say feature VN segment. Sorry, VN segment Vxlan base. Missed it here. I missed it somewhere. Okay. Enable it and feature and we overlay. And we are going to enable the event. I'm not going to enable VXLAN control plane for now. Okay, so just avoid this. I'm just going to create just VXLAN for now. I'm avoiding this. Let's create these three VLAN. So before that, I'm going to make these switches as a root switch for all the VLANs. Okay, make sure that if we are creating the L3 VNI with the Anycast Gateway, all the switches must be the root switch for these three VLAN or 999. Okay, if we suppose one is a root switch, another is non-root switch, then non-root switch will not be able to forward the traffic towards this VLAN. So make sure that all the switches should have the spanning tree perspective active, because why spanning tree? But scenario can be like your L2 network is running. L2 network is running here, and you are connecting your L2 network here, which is running the spanning tree, and your host is sitting behind this, right? In this scenario, you must configure these switches as a root switch. And this can be your legacy network also, okay, for example. So what I'm going to do, let's go to the leaf one. F1 feature VN segment and base feature NV overlay. What I'm going to do here, Going to give a spanning tree. VLAN 1, 150, 151, and 999. Priority, I'm going to give 4096, highest priority, lowest priority. Lowest priority will be always win. Okay. For spanning tree. Now I'm going to create VLAN 150. I'm going to give name L2 VNI 150 tenant 1. We are going to create one VRF, which name going to be the tenant 1. Okay. We are going to be VN segment. We are going to map the Vxlan with the 50,150. Okay. Okay. So what is the Vxlan range? Let's check a look. Vxlan range. This is the Vxlan range. Okay. So you cannot create Vxlan number below to 4096. Okay. If you want to map the Vxlan number, you must map with this digit up to 4000 digit. Okay. Suppose I'm using 50,000, right? You can use 5001, 5002, or 5001. You can start with that. You cannot be below like 3000 something. Or not 3000. You can start, but it's not something recommended. Okay. You can always have 3000 or 2000, but it's not recommended, and sometimes it can overlap with the VLAN. Okay. So VLAN range is still 4096. That's why we avoid to create VXLAN range till 4096. Okay. It can be VXLAN range. Okay. Let's go to the leaf one. Create a VLAN 151. I'm going to create name L2 NI 150 and 1. Oh, I have to go back. VLAN 150 and name L2 VNI 151 tenant 1. Then let's create the L3 VNI, and I'm going to make VN segment, of course.
Sorry to interrupt you. The VLAN, it should be 151, right?
Yeah.
VNI 151. You have given 150.
Sorry.
The second one, the VLAN 150, the name L2 VNI 151, the second one. For this one. Here it
I'm
will
so
be
sorry.
151.
Yeah. I messed up. So, VLAN 151 VN. Already mapped.
You have to remove the no VLAN.
I have removed it here. No VLAN 150. No VLAN 151. Okay. So let's go there. I don't have putty access, so it's kind of getting tough for me to.
When it's really difficult to see the last.
Yeah. I have to type, and I have no option.
Yeah.
If I go to this 150, thanks for pointing out, man. Otherwise, it it would be like nightmare for me to troubleshoot. Let's go to 150. 1. Then exit. Let's create the L3 VNI. Going to be VLAN 999. Segment. I'm going to give what I should keep, what I have given here. Five 50,099, right? 50,999. 50,999. I'm going to name L3 VNI. Okay. So what I have done here, so shall I history? I created this. I get a show run. This is what I created so far. Okay. This is the command I've created. So if I show here, so Vxlan enter, you will see that mapping should be there, VLAN to VNI. Okay. So Vxlan is 150, VLAN is 150, Vxlan with the 50,150, VLAN 150, 50,151. Okay. F2, going to enable feature VN segment waste feature and the overlay. I'm going to copy paste from here, creating.
This VLAN 150 and 150, the VN segment 5051 number is given. It means the A2, yeah, this one.
Sorry?
The A2 VLAN, yeah, this one, this 150, 151,
Uh-huh.
and the VN segment 150, 151, 50. In the A2 VLAN, we are routing with the VXLAN, right? To the VN segment, so that the extra traffic will go through.
I haven't got your point. Your
VXLAN.
voice is not very clear to me, to be honest. Yeah, come again.
This VLAN 150 and 151 segment,
Mhm.
it means we are creating a L2 VLAN through this VN segment so that the L2 traffic will go to
Yeah,
the
so
VXLAN.
we
channel,
are we are converting VLAN traffic to VXLAN here.
VXLAN.
VLAN traffic to VXLAN. Okay. After the VXLAN traffic convergence, we will map this VXLAN to tunnel interface, VXLAN tunnel interface. Okay, because VXLAN is just overlay technology. You cannot go with the data you underlay traffic. It can go when you are using the flood and LAN data plane. Okay. So if I say so VLAN, I'm about VXLAN mapping VLAN. VLAN segment. So VXLAN. Let's go to here. Then we will be spanning tree and 150, 151, 9, priority 4096. So here VLAN 150. Name going to be the L2 NI. Name given to this. And 150, 10 into 1. 150, 10 into 1. Segment VXLAN for this. Segment 50,150, 150, 151. I'm going to give name. Sorry. Why is this showing that there are TCAM table? Because TCAM table has a limitation. We have to increase the TCAM table running the command. Okay. So I will discuss that why is here this coming. 150, name is going to be L2 VNI 151. Tenant VN segment, I'm going to map 50,001. Exit VLAN 999. Name going to be L3 VNI. VN segment 50,009. Exit. I shall show run. The mapping is there. So Vxlan. I'm going to give here feature VLAN segment VLAN base feature and we overlay and going to get VLAN spanning tree route switch for VLAN 1 is a native VLAN going to be 150 151 triple line. Then priority I'm going to give 4096. 96 is given, right? Not 94. Hope sure. Yeah. And 150 I'm going to give. I'm going to give name for the L2 VNI 150. Going to be tenant tenant 1. I'm going to do VN segment. And the VM segment I'm going to map with the Vxlan. Exit VLAN 151. Name L2 VNI 151 tenant 1. Okay. Then VM segment 2051. Exit VLAN 999 transit VLAN name L3 VNI. I'm going to have VN segment with the 50,999. Exit. Now the VNI creation is done. So Vxlan, if I see here, have 3 VNI here. We must have 3 VNI. Yeah, 3 VNI here also. We must have 3 VNI here also. So all the VNI creation is done. Now let's go for further. Let's go and create the L3 interfaces. Okay, L3 interfaces. Now I'm going to create the VRF. Under that VRF, what I'm going to call? I'm going to call this one, this VNI. Okay, in that context. And I'm going to enable RD and RT. What is the meaning of RD and RT here? Okay, so RD, RT are, just give me a second. Okay. Okay, so RT and RT are automatically assigned to in the VRF if you do not keep. RD is used to solve the problem of overlapping in the different VRFs. Suppose you have multiple VRFs, okay, and you are using the same IP addresses in that VRF, and you are making the communication between the two VRF. Okay, for example, let's give here have VRF tenant 1, tenant 2. Okay, tenant A is a VRF name, tenant B. Okay. Now, if you want to make the communication between those VRFs, if you want to make the communication between these VRF and using the 1.1.1, it's going to be overlap, right? So what we are going to tell this VRF, add tag value, unique tag. Okay. So when this VRF send the outside this IP address, it's going to add like something. Okay, and it can add 1.200. So always this IP going to be unique across your fabric, irrespective whether it's the same IP address or different IP addresses. Okay. And let's talk about the RT. So RTs are announced in the BGP as a community, so that receiving leaf switch know that route have to be imported into the which VRF by default. The mixing AS number and VNI number is used for the route target for auto. When you use put the auto, what by default value it takes, like for the RD it takes like router ID and VRF ID. Okay, if suppose router ID what I have given here for the spine switch, I have given the 1.1.1 and the router ID if I say here it's going to be 1 or 2 router ID 2. So like 1.1.1 colon 2 is going to be your RD. If you go for the RT, it's going to be combination of AS number and VNI ID. If I give AS number 6500 and VNI is 50,099, going to be 6500 colon 50,999. Okay, which I will show you that how it looks like when you create that. Okay, this is the uh, route target. I'm going to enable the route target for EVPN also. Okay, for L2 segmentation for control plane. I'm going to give Anycast MAC address also. Why Anycast MAC address? Okay, if I talk about we had discussion for this one Anycast gateway. Okay, Saki said Anycast MAC address means if suppose you have the Anycast global IP address across the fabric, and if this 150 here is created, 151 here is created, right? Each switch will try to use their own virtual MAC address, right? Each switch will try to use their own MAC address, which is not best practice. So what we are going to do, we are going to create one global MAC address. It means one Anycast gateway will associate with this particular MAC address. It will not use local MAC address for each switch from each switches. It will always have the VIP or Anycast gateway with the Anycast MAC address. It means there is no dependency with locally. Okay, globally it will have the unique IP address, unique MAC address to have the uh, actual Anycast configuration. Okay, here if you say that this MAC address will use for ARP replication for default gateways. Default gateway for our case 150 151. Okay, now if I go to this and create the sorry, create the VRF and assign this VRF under the VLAN. Okay, so what I'm going to do here is on the leaf one, I'm going to say VRF context. Oh, shit. Sorry guys. Come on. If one, I'm going to give RF context. I'm going to give name tenant one. Okay, if I go here, so to the VRF, you will see that VRF ID we have for this is 3. Okay, so our RT going to be the, if I say here, so run BGP, what we have the router ID is 8 dot this IP address. If I create the RT for this, just get it's going to be RT like this. For this leaf, going to be like 50,150. Okay, for this particular, this is going to be RT. Similar way, if it is router 9, it's going to be the line with the 150. Okay. Just give me a second, guys. Just give me a second, guys. Stop. Yeah, guys, sorry. Yep. So let's go and create that. Yep. I'm going to create this VRF to all the leaf switches. So VRF context. And one. Make sure that you do not change the different name. Name should be the same for the VRF. It's locally significant. Okay, VRF is locally significant. It will not even impact to other VRF, or it will not go to other destination to telling that this is the my VRF. It's a totally local significant. Okay. So VRF context. And now let's done the association part. Okay. I'm going to give VNI 1999. I'm going to give RD Auto. Sorry, RD Auto. I'm going to give address family IPv4. Unicast. Okay, router target both auto. Port. And to keep. I did not taking the auto. So what I'm going to give here is target import shall I put the route target manually? This is what I'm suspecting. I have to give them this value. So I'm going to use 100 annotation. I'm not able to give that route target manually import. There is some issue might be with the OS something. It should select the auto. Route target. I'm going to give import. I'm going to give 100 triple nine or 49 something. Triple nine, not 4. Then route target. I'm going to import it triple nine EVPN. EVPN want to be there now. Guys, can you please mute yourself? Line. So I've selected import and export both. I have not enabled the EVPN because EVPN feature itself is not enabled. So EVPN command will not select here. Okay. Not been used. So this is done. Let's create the Anycast MAC address. I'm going to fabric forwarding. One. If I say VNI 3009.
Here we are using without NVE, right? It's L2, right? Communication.
No, I'm still configuring that. NV is still not there. So for NV, whether it's a NV or L or whatever you say that, you need NV interface. Whether it's L2, L3. Okay.
Okay.
Just give me a second. I'm going to explain you that what I have done so far. Just fabric forwarding. The feature fabric forward forwarding we have to enable first, then we have to enable this command, fabric forwarding command, then it will work. Okay, otherwise it will not work. Now if I say here a fabric forwarding Anycast Gateway, I'm going to use 1.111.222.333. Okay. Just give me a sec. Okay, so if it is not showing the as expected, what I'm going to do here is going to keep like 000 dot 231 dot 000 dot 2 dot 003. And if I go show CLI history so far, I go to feature. It's kind of overly big. It should be overlay VPN. Why is not coming? VPN. Yeah. And if I go to VRF context and one, you can hide this and give route target. RTDs going to give route target. Excuse me. Address family. Then if I give route target import both, sorry, route target, if I say both auto. If I say route target both EVPN auto EVPN, so run ARF. Okay, this what we have done is we have created one VRF. Under that VRF, we have enabled the EVPN as well as the multiple things. So if I go to this VRF context, yeah, this is VRF context we have created. Okay. So what I'm going to do here, I'm going to say no to this manual is simply select auto. So no need to keep the manual. And okay, going to keep fabric forwarding Anycast MAC address 001.002.003. Done. Now let's go and associate or create the L3 interface. we will create SBI on these all the three switches and allocate IP address, Anycast IP address. So what Anycast IP address we are going to give? We are going to give this same IP address across the fabric, across all the three switches. Okay. And we will associate this particular VLAN SBI under the VRF tenant 1. Okay, which we have created. So let's go and do that on the fabric 1. Interface VLAN 150. So we have to enable feature interface VLAN. Okay, feature interface VLAN. Then you can create the SBI. Let's enable that feature interface was VLAN. Okay, so if I go here, interface VLAN 150, no shirt, VRF member, I'm going to give tenant 1. Okay, the moment you run this command, make sure that before running this command, you do not configure any kind of IP address, because the moment you make that associate this interface with the VRF, all the L3 configuration will be removed automatically. Okay. Then I'm going to give no IP redirect for security purpose. I'm going to give IP address 172.20.150./24. I'm going to configure fabric. No fabric forwarding. No. Why I'm giving this command? If you will not give this command, if you're configuring this same IP address across the multiple leaves, it going to give you the overlap error. Okay, it means same IP address you cannot use multiple times. Okay, especially in the same VRF. Okay, so that's the reason we have to do Anycast Gateway. We are telling each and every switches, this is the Anycast IP address. Do not send or do not think this is the duplicate IP address. Okay, we are making the awareness in the switches. Okay, same thing I'm going to configure for 150 VLAN. Okay, so going to give interface VLAN 151. No shut. I'm going to give VRF member tenant 1 and IP redirect. Okay, then IP address I'm going to give 172.20.151.1/24. Okay, I'm going to give fabric forwarding mode Anycast. I'm telling this switch, this is the Anycast gateway. Okay, interface VLAN 999, and we will associate no shut VRF member tenant 1. We are just going to enable IP forwarding, nothing else for this VLAN, because this VLAN will act as a transit VLAN. Okay, so this VLAN will not have any kind of IP address. This VLAN will have only IP routing enabled. That's it. IP forwarding enabled. It means proxy routing. You can say that. Okay, this configuration we have to do across all the switches. Okay, if I go to here, so first thing what we have to enable in the leaf 2, RD auto, then VNI 50,099. Okay. Then we have to give unicast routing enable. Yes, address family. Okay. So address family IPv4. I'm going to enable the unicast routing. Before that, I missed that I have to enable two features. Okay, for feature forwarding have enabled in Fabric 1. Fabric forwarding, sorry. Fabric forwarding. We have to enable VN and VN overlay. EVPN. We have to VRF text, and we have to give tenant 1. We have to give PNI 3000 9. I'm going to give address family maybe 4 unicast route target both auto. Then I'm going to give auto EVPN. Then I'm going to give fabric. This fabric forwarding will be run in the you can run VRF label, or it's going to run always through the global mode. Okay. So if you see that the moment I enable this command, it will automatically shift me into the global mode. Look here, remove from the VRF. This MAC address must be same across all the switches, okay? Because IP address is going to be same for all the switches. Okay. If I show run, if I copy paste this configuration will be same. If I copy this, okay. Sorry. Interface VLAN. Have to enable feature before creating SBI interface VLAN 150. Then I'm going to give this VLAN something like no shot VRF member tenant 1. Okay, then we'll keep IP address. What IP address I've given here? Okay. Sorry. So it's going to enable this IP address 150.1. Is 172.150.150.1/24. Okay. Then I'm going to enable the fabric mode Anycast Gateway. Okay. Then fabric forwarding.
Can be same, Vijay, for VLAN 150.
Of course, that's what we call the Anycast Gateway. Okay, it means IP going to be same across the 3 switches. That's why if you see that my arrow is going here to there, it means across the fabric. Forget about the 3 switches. If you have 10 switches, you like to have the global one bridge domain kind of. You must have the same IP address across the fabric. It means any switch can use this VLAN and gateway will be the same. Okay.
Okay, suppose if I have one more VLAN called 140, so then I have to create one more Anycast gateway.
Yes, if you like to have the Anycast gateway, if you like to have this VLAN to present across the fabric, okay. If you suppose you do not want to use that VLAN across the fabric, and this is something you want to create locally between the 2 switches, something you can do that. But always recommended to have the Anycast gateway. Okay.
Okay, without Anycast gateway, is it not possible between 2 different leaf?
It is possible. It is possible. It's going to be. It can. You can based on the routing. You can do the other option. But with the VXLAN, why we are using the VXLAN? Okay, because we have the limited.
With VXLAN,
we have the limited VLAN in the production, right? Suppose 4,000 VLAN you want to create. Why you want to create 4,000 VLAN different gateway in each switches, right? Because even though you have 4,000 VLAN, you can create each switch can have the different IP with different MAC address, right? But if you want to create some centralized option for your host, suppose your host is sitting here, 150, suppose in future you want to move from here to there without any problem, you want to move, and you are running the VXLAN concept. That's why we call that VXLAN has the smoothest VM mobility. It means this host can shift from here to here without any zero touch configuration in the fabric, because gateway is the same, right? You can just plug and play one interface from here to there and they can make the communication. You can make the communication without changing anything in the fabric.
Yeah, that is what in VXLAN without Anycast Gateway it's not possible, right?
It is possible. It is possible without any cast gateway is also possible. Okay.
Like what you said, one rack to another rack without any fabric change we can do, right?
Yeah.
Without
Yeah.
using
That's
Anycast
something.
MAC, right?
Yeah. Without something, that's something you need any cast gateway for smoothest migration. For smoothest migration. Okay. Suppose you are sitting here in the legacy VLAN, you're sitting 150 VLAN. Okay. As of now, they are using this gateway here. Suppose your company decided to decommission this L2 device. What you can do, directly connect your one interface to one of the leaf switches, any of the leaf switches. You just have to create the access port here. That's it. You do not have to touch VXLAN. It will automatically move your traffic because they have the same MAC and gateway what they had in earlier.
Okay.
So if you have, suppose you created 4,000, suppose you created 4,000 total Anycast gateway, right? And you want to move your existing infra to this infra, you just configure one time your fabric and you just keep moving your VM from legacy to here without any changing this infra. Because what usually happen when you create the any kind of migration scenario, you just move one by one, right? You just
Yeah.
create one single unique gateway for entire fabric and just keep moving. Just tell your team, just keep moving. We do not need to do anything in the we do not need to be in configuration on the VXLAN level because we have already completed all the things.
Vijay, to be frank, I'm having here many doubt. I'll ask in at the end of class.
No problem, no problem. You can we can sit together, okay, on this.
Okay.
Then 151 I'm going to create. Shut RF member and one. Update this 172.151.24 fabric forwarding on Anycast gateway. Shut interface VLAN 9 shut IP RF member NN21. Oh, create a new tenant. No. IP forwarding. So serial history done. So VRF is capital, right? So make sure it's not show on VLAN. It's then U1. This looks okay. This is done. Oh, I forget that one more thing. Interface. Oh, IP direct.
Vijay, we don't need to use RD command in list to switches.
RB command means
RD.
yeah, already done. If you see that show run, I have already used that RD command under the VRF. Where is that? Look here.
Oh yeah.
Okay, it's already done. For the leaf 1, leaf 2 is done. Let's go for the leaf 3.
And why we are giving auto here when in RD?
Okay, there is two
we
options.
can-
There is two options. Either you can give the auto and give the default value of your this one. If you give auto means it will mix your the AS number of the BGP with the VNI ID. Okay, but and for the RD, it's going to be the router ID and VRF ID. If you like to give manually, you have the option to give that. Okay, uh, to be honest, auto is the best practice and best option which you can use, because if you are going to see that this one ID and VNID, so you do not have to worry about creating unique VNID like this one. If you have 10 VNID, you have to create 10 times this one, right?
Yeah.
But if you give auto, it will automatically select the unique VNI ID for you with the AS number.
Okay.
So you are avoiding the extra unnecessary configuration. And to be my perspective, this is the best practice also. Okay. And we overlay EVPN, then integrate fabric forwarding. Anycast gateway. Sorry, enable the feature fabric forwarding. Yeah, then this command. Same MAC address 0.0.01, 0.0.2. I'm going to create this VRF. I'm going to give VRF. VRF is already created, so VRF context tenant context tenant 1. So VRF. Okay. Let's go and create that. For the configuration, VNI, I'm going to give 50,999. RD going to be auto. Address family for Unicast. Route target, I'm going to give both import and export auto for BGP as well as for EVPN. I'm going to give fabric forwarding Anycast Gateway. I have done the amendment in the chat. This sheet you can use different sheet whenever I will. I'm going to get feature interface VLAN, and I'm going to get VLAN 150. Sure, I'm going to make that 11 of the VRF tenant member. This command is not. VLAN 150. RF member. Okay, then I'm going to give IP address. I'm going to for that no IP redirect. IP address 20.150.1/24. I'm going to create this as a Anycast gateway. Anycast gateway. Shared. Interface VLAN 150. sorry, 151. We're going to give VRF member tenant 1, IP address 172 dot fabric forwarding. Going to get mode Anycast gateway. Then create VNI transit VLAN SBI. Going to give shirt member and one. Then going to RP forwarding. This is done. Now we have to create the VNI. We have to create the NV. We are going to create the NV interface. First thing is, okay. For the same, all the leaf switches, we are going to give same command. So what we are going to do here, VNI 150, VNI 151, we are making that as a L2 VNI, and we are 50,090,999, we are going to give as a L3 VNI. So what the meaning of associate VRF here? Okay, this VRF, this attribute will be used to separate process VNI that are associated with the VRF used for the routing. Okay, so whatever, if I the moment I give here this one, whatever VNIs are present in this particular or in this particular VRF which is associated with this one will be by default redirecting traffic towards this one. Meaning, if you see that I've given the this command, RD command here, right? RD command here, and this all the VNI are created here as a L2, but we have not given any RD command for them. Meaning, these are the L2 VNIs will be used as a gateway and will be redirected towards the this particular VNI. Okay, because they are in the tenant 1, and I'm telling this NV interface use the tenant whatever present, whatever is available for this VNI. Okay, the moment VNI will initiate the moment VNI L2 VNI, this VNI will initiate the traffic for the L2 L3, it will directly go for this one because this is saying that I am the transit route for you using the L3 VRF. Okay, source interface, I'm going to use loopback 1. If you see that in the leaf switches, what the loopback address we are using. So IP interface brief, loopback 1 is this web IP address. This is totally dedicated for the VNI L2 into your Vxlan tunneling interface. Okay. Say here loopback 1, you can see the NV interface. Okay. Now, if I go to leaf 1 now, we are not touching anything to spine switches, guys. Make sure that okay, we are playing with the leaf switches now here. Okay, now let's go here and interface NVE1, getting the Vxlan tunnel interface 1, which is name. You can like interface NVE. Interface NVE. You have a range. But always keep the 1. Okay, 1 not shut. Then come to use source interface as a NV Vxlan source interface going to be the loopback 1 from my device. Okay, then I'm going to say host reachability. It means this communication will be happen through the BGP reachability host BGP command. Activate the EVPN address family for the VPN for tunneling. Why this BGP activating the EVPN family? Because the moment you run the BGP on top, the moment you run the EVPN on top of the BGP, there is mutual explicit redirection happen between the EVPN to BGP. It means whatever EVPN will have the MAC address or IP address, it will redirect to the BGP. Whatever BGP will have in the table, it will redirect to the EVPN. Because EVPN cannot single-handedly cannot take your L3 traffic, because EVPN and VXLAN is a L2 protocol. It's not the L3 protocol. So it needs some sort of a control plane mechanism to make the communication. That control plane mechanism is a your BGP here. Okay. And protocol BGP. Okay. Then I'm going to give member VNI. It means I'm making that member. I think that my 50,150 VLAN going to be part of the multicast member cast group. Sorry, cast group 239.0.0.1. Why 239? If you see that it's fine switches, it mean 1, 2, 3. See here. So run PIM. You will see here PIM has this range. It means if you calculate using the calculator, IPv4 calculator, sorry, I show you guys. Please collect /4 for 224.0.0.0. I can give IP address to my VNI in this range only. So I'm giving my IP address to this range only. We are not changing anything others. It means the moment I will give this VNI to this group, it means I'm telling my leaf, if you have unknown traffic or broadcast traffic or multicast traffic, send to my RR for L2 communication. For L2 communication. Okay. For L3 communication, you go to this VNI using the VRF tenant. Okay. So let's go to this. Let's go to the member VNI 151, then MCAS group 239.0.0.0. Okay, I'm going to give member VNI 50,000. Then we have associate VRF command. Okay, I've explained the why associate VRF. Associate VRF will be used for the routing purpose, for inter-VLAN routing purpose. Okay, same command we have to put on the all the switches. Okay, for leaves 2, so let's go to the leaf 2. Exit interface NV. I'm just creating the tunnel interface. If you see that this one, I have done this configuration, all the SBI configuration, all the things. I'm creating this L3 tunnel or NV interface on this all the switches. Okay, and associating this tunnel interface to VRF, and this single NV interface can carry VRF and non-VRF traffic. Okay, just make sure that it can carry your L2 traffic, it can be carry your L3 traffic. So you do not need to create separate NV interface for L3 and L3 traffic, L2 traffic. Okay, then go to no shut. Source interface I'm going to use as a loopback 1 because I have dedicated each and every leaf switches one interface for this NVE Vxlan source. Okay, that VLAN, that loopback 1. So host reachability protocol BGP I'm going to use. I'm going to make that member VNI 50,150. MCAS group, I'm saying that use if you have L2 traffic, you use this IP address to identify yourself with the group. Okay, member VNI 50,151 MCAS group 239.0.0.150. Saying that member VNI 50,999 associate. This is what I have command given. shut. Show IP interface B. Make sure that all the interface should be up and running. So interface status. All the interfaces are up and running. They are routed interface. So run interface VLAN 150. Fine. Fine. So interface status. Fine. So interface VLAN. Make sure that members are fine, up and running. Now let's go to the leaf 3. Okay, so if I go to leaf 1 is done, leaf 2 is done, leaf 3 we are going to do that. Okay, leaf 3. So leaf 3 I'm going to click exit. So run interface VLAN, sorry. Fine. Okay. I'm going to give interface NVE1. Okay. NVE1 and going to give just going to give source as a source interface loopback 1 host reachability protocol going to be BGP, then going to be member VNI going to be 50,150, which going to use MCAS code 239.0.0.150 member VNI so run interface NVE1. So run interface NVE1. This is what we have done so far. If I go to here, show NVE, so run interface NVE1. Okay. Now if I see that, so NVE1, I say I have not enabled the control plane. Okay, just make sure that I just enable that Vxlan. We have not enabled any control plane protocol for now. Okay, we have not enabled the EVPN. Okay, what I have done so far, created the VNI, created the SBI Anycast Gateway, created the tunnel. I have not created the BGP EVPN feature on the any switch of the switches. Without that, if I say so interface NVE1, saying that okay, this is up through the hardware, encapsulation is Vxlan, this is the MTU size. One thing, have you guys noticed that I have not created any MTU interface for now? Okay, so if I say here, so interface Ethernet 1+1, what is saying that all the interfaces are using the 1500 MTU size, which is not best practice. So I have to create L2 and L3, all three MTU size. Okay, so if I say here, system MTU 9216, all the switches, so L2 traffic. Okay, system Jumbo MTU 16 interface, sorry, system Jumbo MTU 9216. Because why creating that? Because NV interface itself has the 9200. If you see here, so interface NVE1, you will see that this is the Vxlan cache. If you do not have this MTU size in your fabric, your Vxlan traffic will be dropped. Okay, just to make sure that. Now I'm going to enable Jumbo MTU on the interface level also. Net 1/122 MTU. I'm going to use MTU size 9216. Same here. That's 122. MTU type 126 for L3. 9216. It's fine switches also. Make sure that that's a prerequisite, that you can note that that's a prerequisite. You must have the Jumbo MTU for L2 and L3 traffic. For L2 traffic, you do not need to give MTU size on the spine switches because spine switch will not have directly L2 traffic tunnel, but it still is recommended to have the Jumbo MTU. Jumbo MTU 9216. Phase 1/123. MTU size 9216. Okay. I'm going to give system Jumbo MTU 9216. 3 MTU 9216. Exit. So one. Okay, all the interface got the MTU size. See here. So run. All the interface MTU. So why I'm not enabling MTU size on the loopback interface? Because loopback interface eventually they're going to use the physical interface for transportation, right? So they do not really need that MTU. It's up to you. Like you want to use physical MTU size or you want to dedicate the MTU size or loopback address. So run. See all the MTU size are enabled. Okay. So there is two types of MTU, two way to enable the MTU size. MTU. Either one is from the QoS policy, second is from the manual per interface basis. Okay. If I go to leaf switches now I say here, so VNI, so NVE, if I say VNI or all, I have 3 VNI which are up. Okay. Let's say all. It's showing that we have 3 VNI, all are up. They are using the control plane. They are using the control plane, not data plane, because they are part of the VRF. Okay. Now, the last thing is we have to enable the control plane EVPN for on the spine switches and the leaf switches to contain the traffic. On the spine switches, what I'm going to do here is this. Just give me a second. I'm going to enable EVPN. This is for all the leaf switches. I'm going to be spine switches also. Yeah, this is the for spine switches. So I'm going to just enable the community and route reflector under the EVPN. Okay. So what I'm going to do, going to spine switch. Going to spine switch here is spine switch 1. I'm going to say router BGP 6500 for my case. address family L2 EVPN, L2 VPN EVPN. Why this feature is not accepting? Because feature is not enabled for EVPN. That's the reason EVPN is not accepting. Okay. If I go to here, I have to enable the feature. Just give me a second. Just give me a second. Let me open my another sheet. Okay. I might have to enable. Then I have to enable EVPN here. Just give me a second. The ping is done. Router, this is done. We have to this is already enabled for leaf switches. So for leaf switches, we do not have to worry about the EVPN feature. For spine switches, we have to contain run EVPN feature. So this must be supported VPN. Yes. So we have to create the EVPN feature, the other switches. So if I go to here, this EVPN feature, I'm going to click exit feature. Okay. Our Bgp 6500. Bgp 6500. I'm going to give like address family L2 VPN EVPN. Okay. Then retain route targets all. Not going to change anything and complete here. Leave here. Then I'm going to say address family L2 VPN EVPN. Send community for these both, like we were sending for the BGP route reflector. Just use a reflector as a client for the neighbor. That's it. If I show here, show run, sorry, show run BGP. If I go here, you will see that this command should be reflecting. EVPN command is already there. This is already there. If you see that send community for EVPN, yep, it's added here. And route reflector is already here. Yeah, only here. So name is same. Come on. Sorry guys, I created the wrong template name. 150 BGP 6500 this family L2 VPN EVPN will retain route target all. In template I'm going to call template peer leaf peer name address family L2 VPN EVPN same community both node refactor line. I go to here, so run BGP. So we have the peer and I added L2 VPN. So I'm going to router BGP 6500. So run BGP. Right. Now let's go and same thing we have to do on the spine switches. Have to enable NV overlay EVPN. Okay, we have to enable this EVPN feature on the spine switches. Then we have to give a router BGP 6500 address family L2 VPN EVPN. Okay, I'm going to give retain route target for all. Then I'm going to give template. Going to give existing template should be override. Okay, not the new template. Peer if peer going to give address family L2 VPN EVPN. Going to give send community for both extended and route reflector and then exit. So run BGP. Let's verify that whether the configuration is it or not. So this under this we have the L2 VPN, send community, route reflector, all the things are in place. Okay, perfect. Let's go to the leaf switches. Now on the leaf switches, we have to send the community for this one. So on the leaf switches, features are already enabled. So if I go to tab 1, router BGP 6500, address family, L2 VPN, EVPN, retain route target for all neighbor 1.1.1 is spine 1, which is remote AS under 6500. Address family going to be L2 VPN with EVPN. I'm going to send community for both standard and extended. Then I'm going for the neighbor 2.2.2 spine 2. Going to say remote AS 6500. Remote AS 6500. Address family L2 VPN EVPN. Send community both. Okay. Now this is done on the leaf 1. If I go to the leaf 2, same thing we have to enable the control plane, router BGP 6500, BGP 6500, address family L2 VPN EVPN, globally we have enabled. Then I'm going to say retain route target all under the neighborship of spine 1. Remote AS 6500, address family L2 VPN EVPN, send community both remote AS 500 both. So same commodity both. Same thing I'm going to replicate in tab 3. Feature is already enabled. Router BGP 6500. Going to address family L2 VPN, EVPN, retain, route target all. Okay. The neighbor 1.1.1.1. Then going to remote AS 6500 VPN. Same command for both standard extended. Neighbor going to be 2.2.2.2 spine 2 remote AS 500. This family going to be the L2 VPN, EVPN. Same commodity. Okay, so control plane enablement is done. Okay, so run BGP. Is done. This command is done. This command is done. If I say that what feature we have to enable, so run NV. To make sure that you enable this feature. NV overlay EVPN. This is the feature which you have to enable across the all leaf and spine switches. Okay, in order to make that control